Hello there, college algebra students. This is Mr. Kashi speaking. With this video, we're going to go through our last day of notes in Chapter 6. This is finding inverses of matrices. There's a handful of things throughout these videos that I really wanted to dive deeper in, as if we were in the classroom, but I've held back and just kind of gone through basic things and making sure that we're getting the skills down if you ever needed to go obviously take a calculus class after this. So this is how to take an inverse of a 2 by 2 matrix. Here it's just, you've seen this before. If we had a matrix A that looked like this, it is invertible if the determinant is not equal to 0. So hopefully you can see, and then we have then if it is invertible, then this is how you find the inverse. So this is the inverse formula. And hopefully you understand that we have what we call the determinant. That's what we did last time. We found the determinant. That's here, but we also put it in our inverse formula as well. So it's in two different spots. We don't just find it to determine whether there's an inverse or not. We actually find it for the inverse. And hopefully you can see it can't be 0 because we're dividing by it. We can't divide by 0. So that is the denominator in that fraction. And if we were to start with matrix A, hopefully you can see the difference here is that we're actually taking A and D and switching places from here. Sorry, I probably should have put the arrow up here. That's what happens down here. And then we're taking the opposite of B and C, and we're multiplying it by this fraction out front. So really the two steps is 1, find the determinant, and then 2, use this formula to find the inverse. So we'll go through, I think we got 3 examples here. So first we have to find the determinant. And the first thing you do is we go A times D. So we have 6 times negative 2 minus, then we have B times C. So we have 3 times negative 5 equals, so here this would be negative 12, and this would be minus negative 15. So here we would get, remember that's change, so we would get a positive 3. So coming down here, we would find our inverse matrix of 1 over 3. That's where this comes from. We have 1 over our determinant. And then we have D up here, so this would be negative 2. So remember these two switch places. Okay, so that'd be negative 2, and this would be 6. And then this would be a negative 3, and then this would be a positive 5. So we're just doing the opposite of what's there with the C and the B. And then we just multiply it out. So here we have negative 2/3, we have 5/3, we have negative 1, because this would be negative 3 divided by 3, and then we would have 2, because that would be 6 divided by 3. So that would be our inverse matrix. And if you can remember from a couple of videos ago, if we were to multiply our original matrix and this matrix, we would get the identity matrix of 1, 0, 0, 1, just like that. So yeah, this is how you would find the inverse of that example. Moving on to another example, here we have, we'll go 12 times 3, which this is 36, and then we have negative 4 times negative 9. That's a positive 36 as well, and that makes 0. So therefore, inverse does not exist. And we know that because if we can't put a 0 underneath, we can't go 1 divided by 0. That's against mathematical rules. So if you have something, you can't divide it into 0 groups. So that is the reason why we say that the inverse doesn't exist, because how we find it is using that as the denominator. So moving on to the last example here. We have negative 2, 7, 1, and 8. So we'll go 1 times 7 is 7 minus negative 2 times 8. That would be a negative 16. And then that, remember, change. So that would actually be a 23. So coming over here to find, let's call this matrix B. So to find B inverse, we would say it'd be 1 over 23. And then we're going to multiply it by, we have 8 up here, negative 2 down here. Remember, these two switch places. And then we have a negative 1 and a negative 7. And this is a case where all of these, the 23 is a prime number, so really this isn't going to be able to reduce. So we have just 8 23rds, we have negative 7 23rds, negative 1 23rds, and negative 2 23rds. And that would be your B inverse matrix. So just a couple of steps to follow. Make sure that you remember about the change. Maybe use a calculator there if you need to. But then obviously follow your inverse formula here, which is driving these whole problems. Hopefully these examples were helpful, and I am always available for questions.